Hey, welcome back everybody to lesson 54 of the Dead Earth game development series brought to you by the Game Institute. I'm Gary Simmons, and in this lesson we are going to work on our generic trigger script. Now that might sound a little mundane and not very exciting, but believe me when I tell you it's anything but. In the Dead Earth prototype, the generic trigger script was responsible for pretty much all of the gameplay stuff. It was responsible for spawning hordes of zombies, for turning lights on and off, for playing sounds on cue, for all of the various quest steps, and basically just the game logic. Using our generic trigger script, we will be able to enable and disable entire game object hierarchies, including particle systems, lights, and sounds. We will be able to send multiple parameters into multiple animators. And in the Creeper minigame, the generic trigger switch is going to be used in a few different places, but most predominantly on the power generator. And when we activate that script, it's going to do a whole load of things. It's going to change some of the material properties, so all of the light sources in the level have emissive materials on them so they glow white. It will also enable different game objects that have sounds on them that are set to play on awake. So we're going to hear a lockdown message in the background playing over the tannoy system. It's going to enable engine sounds for the generator, and it's also going to turn on lots of light sources in the scene. It's also going to set states in our state dictionary, and will also enable other sub-hierarchies such as the computer system, which means we can then visit the computer system, which will now have power, and then we can deactivate lockdown. Furthermore, the generic trigger script will be used in a much simpler example, such as to represent the access code which will be placed randomly on one of the dead bodies that we place around the scene. Now, the generic trigger script isn't that complex, but it will need a few support classes that we're going to have to write first. As with most things in game development, the first step is imagining what you want to happen in the game, and then designing the code, and finally writing the code to realize those goals. So what I would like to do now is just pop forward in time to the final Creeper minigame so I can show you exactly what this generic trigger script has to do, how it works, and then we're going to examine the scene and discuss how the various game objects have been set up such that they can benefit from the trigger script and create this entire sequence where we have a computer system that is dependent on the power generator being on and so forth. So let me now flip over to the final version of the Creeper minigame that we should have finished in the next 2 or 3 lessons. So here I am in the final Creeper game. What I've done in the level is I've turned off all of the zombies so that I can demonstrate to you the interactive items, and in particular our generic trigger script, without me being hassled by zombies. So let me go into play mode, and let's first of all take a little look around so we can see a few things of note. Like, first of all, if you look at the light sources on the elevator shaft, and these light sources here, you can see they start off in the off position. Those lights do not look on at all. That's one of the things that's going to change when we activate the power generator. Something else I want to show you is if we go over here into this room, you can see we have the computer system. And the computer system is also off. When we walk up to it, nothing happens. That's because we haven't restored power to the level yet. So now let's go and have a look at the generator. Now, let me turn my flashlight off so you can kind of see what's happening. The power generator has an interactive trigger script on it. And this little metal button here is the switch that when we activate, we will see that animate in. And as it animates in, we're going to hear like a metal scraping sound, which is that big metal switch being pushed in. And then what we're going to hear is a sound of the generator starting up, like an engine starting. And there'll be a second or so of delay, and then the engine starting sound will be over, and it will be replaced by the engine running sound, which means the power generator is now running and supplying electricity to the level. Now at that point, quite a lot of things will happen. First of all, we're going to see that this red light, it's a little bit burnt out in the scene view, but this red light here is going to turn to a green light. And there's also an emissive material on this little light bulb here, which will also turn from red to green. So this whole area, instead of being bathed in red light, as it is at the moment, will be bathed in green light. And the power generator will have a green emissive material on the little power light bulb here. The next thing that will happen is we will hear an announcement over this speaker system here, this public address system, that will say something like lockdown has been initiated. Another thing that will happen is if I go back to the other side of the level, you're now going to see that when we come back here, all of these light sources are now glowing bright white, and this whole part of the level over here by the shaft will be brightly lit. And the effect of that is obviously two things. First of all, these materials on the actual light bulbs themselves need to turn to white emissive materials, and we're also going to put a bloom filter on that so they glow nice. And we're also going to place some white point lights around this area of the level so that it looks like the level is being bathed in the white light from these light sources. And those game objects too will need to be enabled by our power generator trigger. And the final thing, perhaps more importantly, is if we go over into the room where the computer system is, this computer screen will now be on. This black texture on the screen will be replaced by a red texture that is asking us to press the E key and hold the E key to deactivate lockdown. And so let's see what it looks like. Okay, you ready? So remember all the things I told you. First of all, we're going to get an animation of the button with a sound. Then we're going to hear the engine start up. Then we're going to hear a sound being played over the public address system. And then we'll go and look at the lights over the other side of the level. And finally come back to the computer system. And the computer system is really interesting because we don't just flip a texture on the computer screen, but we essentially activate an entire hierarchy over there that allows us to create another puzzle in that room. So, are you ready? Here we go then. Sound and animation, then the engine starting sound, then the material switch, so we can see there's a green light on the generator, and we can see that this area is now bathed in green light, and we can now hear the sound over the public address system.
An automated message being broadcast on the Simtech emergency broadcast channel.
Let's now go over to the other side of the level and have a look at those lights I was telling you about. You can see from here already that they're on the elevator and they're glowing white. There you go, look. And those lights are on there too. Look at that nice bloom on those lights. And of course all of this area now is now also bathed in white light, looking like it is actually those polygons there that is illuminating this area. But let's go and have a look at the computer system, because this is now a new puzzle that is open to us that wasn't open before. So you can see there's a red light now that is emanating from the computer room, and that's supposed to be the glow from this computer screen. Now of course it isn't the glow from this computer screen. What happened when we turned the power on is not only did this texture get flipped, so it now says the Simtech operating system lockdown activated, hold the use button to deactivate, but there's also a red light that is enabled and makes it look like that color is coming from the screen. So what happens in this screen now is we've not just flipped a texture and turned on a light, but we've activated an entirely different game hierarchy that has a trigger on it that is waiting for me to press and hold the E key. And as you can see, as I hold down the E key, we see this little bar going across the screen, and if I hold it long enough, lockdown will be deactivated, and if I let go, it resets back to the beginning again. And what's really cool about that is you can imagine how tense it is if you're waiting for this thing to unlock, and that you can hear all the zombies behind you, and you're hoping that one doesn't discover you in the room before you have to let go and go and hide behind a wall to get out of their field of view. But if I hold it down long enough, as you can see, the texture changes. The red light is disabled and a blue light is activated, so the whole room is now bathed in blue light. We're no longer hearing the sound over the public address system saying that lockdown is in progress. And the text has also changed on the computer screen. And what's also worthy of note is that little bar system that goes across the screen when we hold the E key down is actually done by placing a world space canvas in the scene. So we're using Unity's UI system again, but this time to create a world space canvas that we overlay over the top of this texture here. So now that lockdown has been deactivated, if I walk over to the elevator, I still can't escape the level because I haven't found the access key. The access key isn't related to the generator or the computer system. It's like a separate little puzzle that we can solve in any order. And as you can see, if I go back to keypad, it says access code required. So what happens in Creeper is there are several dead bodies placed throughout the level. Here's one here, and the access code is placed randomly on them. And just by a sheer fluke, the first body that I came to had the access code on. There's two other bodies that it may be on. It's going to be different every time you press play. But in this particular case, it says here there's an elevator access code, and when I press the use key, I essentially collect that access code, and we hear a little beep beep. There you go. And the access code is now gone, and all of the states have been set so that I can now return to the elevator and hopefully activate it. can also see some things in the level that have beautified this a little bit. We now have a skybox, better lighting and shadows, and we're going to do all of that as well. You can see finally, you've seen what happens when that mission complete message comes up. It then takes us back to the main menu screen of Creeper, where we can either play again or we can quit the game. So now I'm going to go back into the final version of the game again, but this time I want to examine how all the game objects in the scene are arranged, because understanding how the scene is composited is pivotal to understanding the power that you can gain from just being able to enable and disable game objects, to set material properties on the fly, and send parameters into animators. So let's start by selecting the generator game object in our hierarchy and examining all of its sub-objects. What I want to look at first is the inspector for our generic switch trigger. So let's select the switch trigger sub-game object, and in the inspector you can see the script that we're going to create. Now there's quite a lot involved in making this effect happen, so we may not get everything done in this lesson. It may have to spread over 2 lessons, but let's just see how we go. If you look at the inspector, the first thing you'll see, it has under the heading of game state management lists where we can set required states, active states, and deactivate states. The required states are where we get to specify a list of states that need to be true in order for us to be able to activate this switch. Now in the case of the generator, it has no prerequisite states, but of course if we wanted to have some prerequisite states like our elevator keypad, we could put a value of say 2 in there, and then we would have 2 elements in this list where we can type in key value pairs, but I'm going to set that to 0. The next list of states are the states that we would like this script to set when it is activated. And as you can see, the active states on this particular switch contains just one state, where we set the power state to true. And we saw in the last lesson that the power being set to true is one of the prerequisite states of our elevator keypad switch. The third and final list of states is the deactivate states. These are the states that we would like set when this object is deactivated. As you can see, the power state is set back to false. But what I also do is set lockdown to true. This means that if we have previously switched on the generator, gone into the computer room and deactivated lockdown, turning off the power again will reset that status. This is just a personal choice of mine. I just thought it would be cool if you turn the generator off, it kind of reboots the system so that when you turn it back on again, the computer is once again in a lockdown state. So those are the 3 state lists that this generic switch can manage. Next up, we have the message section. This is where we get to specify the text that is sent to the HUD depending on the state the object is in. The first text box is where we get to specify the text that should be displayed on the HUD if the prerequisite states, the required states, are not met and we are unable to activate the switch. Because this particular switch has no required states, I've just set the text to not used here, just to let me know and you guys know that this text should never be displayed. Next up, we have the text that should be displayed on the HUD when all of the required states are true, but the switch has not yet been activated. It says on the HUD, power generator, not running. The third and final text box is where we get to specify the text that should be displayed on the HUD when the switch has been activated, in which case we say power generator running. Next up we have the activation parameters, and the first 2, activation delay and deactivation delay, of course are very much like the activation delay that we built into our keypad switch. The activation delay here is 4.54 seconds. When we activate this switch, the parameters will be sent to the animator, the activation sound will begin playing, but only once the activation delay has elapsed will the configurable entities section be executed, and we'll look at those in a moment. But basically that's the lists of materials, animation parameters and objects that we have to activate and deactivate. We specify the activation sounds to our switch as an audio collection. This script expects the activation sounds to be in bank 0 and the deactivation sounds to be in bank 1. This script should also make no assumption about whether we wish this to be played as a one-shot sound or not. So instead, I allow us to specify the audio source that should be used to play the activation and deactivate sounds. I have assigned an audio source called timeline. If you look at the child objects of our generator, you can see that the timeline audio game object is simply a game object with an audio source on it, ready to receive a sound. At the bottom of the activation parameters in this version of the script, I also allow us to specify the audio group that the sound should be played on. However, in the new version that we're going to create, I'm not going to expose this parameter, as it makes much more sense to take the audio group from the audio collection that has been assigned. Next up, we have the two operating mode parameters. The first one is whether this switch should start in an active or deactivated state. In the case of our power generator, start activated is unticked, which means we wish it to start in a deactivated state. Also, it may not be desirable for some switches to be toggled on and off. This particular switch can be toggled on and off. In other words, we can activate and then deactivate the generator if we want. But some switches, such as our elevator keypad switch for example, shouldn't be toggled on and off. It just allows you to activate it. As you can see, we have the can toggle boolean that allows us to specify whether this switch should be allowed to be activated or deactivated more than once. The final section is the most interesting and probably the most important. It's the configurable entities section. You can think of this section as being a series of lists of instructions to execute that will modify the scene in one or multiple ways. At the top, we have the animations drop-down. This allows us to specify any number of animators along with a series of parameters to send into those animators. On this particular switch, we have only one element in the animations array. As you can see, the first member of each element is the animator for which some command should be executed. In this case, it's the button animator. We'll look at this animator in a moment. Following the animator component reference in each element in this list, we also get to specify a list of parameters that we would like set in the animator. This switch only wishes to send one parameter to one animator. In this case, we are specifying that we would like to alter the value of a Boolean parameter in the animator whose name is activated, and the value we'd like to set it to is true. So where is this animator? Well, let's select it in the scene hierarchy and then select the game object that has this animator component on it. As you can see, as a sub-object in our generator hierarchy, we have the generator switch. This has its own little mesh and its own animator that animates the button in when we activate it and out when we deactivate it. Let's take a look at the animator for this button. As you would expect, it has a Boolean parameter called activated. It also has two animation states. The first state is an animation of the button being pushed in. The second state is an animation of the button being pulled out. As you would expect, the transitions from one to the other are when activated either equals false or when activated equals true. So when we generate our trigger switch, the trigger switch will set this activated boolean to true, causing an animation to play that will animate the button into a depressed position. The reverse is true when we deactivate the switch. Furthermore, if we select these two animation states, you can see that they have a new state machine behavior on them that we will also write, called audio on enter. We simply assign it an audio collection and a bank, and as soon as this state is entered, a sound will be chosen from the respective bank and played. In the case of our generator switch, when the button is activated or deactivated, I play the same sound. It's just a metal screeching sound. The interesting thing here is that the switch itself is not responsible for making the sound of the button being pressed. That is triggered by the state machine behavior on the animation states. So going back to our switch trigger, we now see how the first part of this sequence works. When we activate the button will immediately send a value of true into the activated parameter of this animator, causing the button to be pushed in and a metal screeching sound to happen. After a short period of time, the activation sound will play. The activation sound is the sound of the engine starting up, and it lasts for a couple of seconds. Unlike the other lists in the configurable entities section, the other lists are only executed once the activation delay has elapsed. Let's now have a look at the material controllers list. This particular switch uses two material controllers. As you can see, this is a list with two elements in it, and each element is a material controller. The material controller is a class that we will create. The material controller contains a reference to a material in our project, and a series of properties to set in that material when the switch is activated. What we're seeing here is that when this switch is activated, a material called emissive green will be set to this emissive green color with an emission scale of 1.4. Basically, the emission scale is multiplied by the emission color, and that gives us an HDR color that will react well to the bloom screen effect that we will add later. The emissive green color is being used on the light game object in the generator's hierarchy. Let me turn off some of these other light objects a minute so we can see exactly the object that I'm talking about. As you can see, we have this little power indicator light on our generator, which is initially set to red. If you look in the inspector with this object selected, you can see that it uses the emissive green material, but at scene startup, it's actually set to an emissive red color. The first element in our material controller's array stores a reference to that material and also stores the emission color of green that it would like to change to when the switch is activated. In other words, if we were to do this manually, it would look like this. So that's what the switch is going to do. It's just going to do that. If we go back to the switch trigger, you can see that material controllers also provide the ability to change the diffuse texture, the diffuse color, the normal map, the strength of the normal map, and an emissive texture. Of course, there are many more properties that we could set in the standard shader other than these, but these are the ones I currently support. But you can feel free to extend this class when we examine it later to support all of the properties that you want. The next element in the material controllers list is a material called Prop Battle Bus Lights Effects. Let's select it in our project and call up its inspector. To understand what this does, we need to go over to the elevator, and you'll notice that going up the elevator shaft we have several of these lights, and also dotted around the elevator on various walls we have lights also. Furthermore, we also have these big floodlights here, and the glass sections of these lights all use the Prop Battle Bus Lights Effect material, which has a black emission by default. What our generator's generic switch will do when it is activated is it will change this emission color from black to white. This will make all of the lights that use this material glow emissive white. Let's put that back to black for now. So you can see already our generic switch has turned on all of these lights. It has also turned the light from red to green on the generator itself, and it's also played an animation and a sound of the button being pushed in, and also played the sound of the engine starting up. Let's select our switch trigger again. The material controllers class is just a little bit more complex than you first might think. In Unity, when we change the properties of materials at runtime, those property changes persist us exiting play mode. We don't really want that. We want when we exit play mode for all of our materials to revert back to how they were before we pressed play. Therefore, our material controllers will back themselves up and register them with the game's scene manager, so that when the application is exited, all of our material controllers can reset the properties of their managed materials back to what they were before we entered play mode. Next up, we're going to look at the object activators list, by far the simplest list to understand, but really the most powerful. The object activators list is simply a list of game objects that we wish this switch to enable when it is activated and disable when it is deactivated. As you would expect, the object deactivators is the polar opposite of this. It contains a list of objects that should be deactivated when this switch is activated and activated when this switch is deactivated. But let's look at the object activators list first. The first game object in this list is called Light On, which once again is another child game object of our generator construct. Currently, it's off. When we turn the generator on, this light will be turned on. It is a green point light which lights the surrounding area in a green light. Coupled with switching the material of the physical light mesh on the generator from red to green, this gives the illusion that this is the green light that is being emitted from the green light mesh on the generator. Of course, when the object is deactivated, this light comes off, and in the object deactivation list, we have the red light that comes on. So the light on and light off represent the lights that should be used when the generator is on and off respectively. Of course, the starting state is the generator is off, so light on would be disabled and light off would be enabled. Going back to our switch trigger again, you can see that the next two game objects that we activate are called Audio Announcement and Engine Sound. Once again, they are both game objects in the hierarchy of our generator construct. Engine Sound is simply a game object with an audio source on it that has been assigned the generator running sound. This is a looping sound that plays endlessly while the generator is active and makes the sound of the engine just ticking over. Because this is set to play on awake, the moment we enable this game object, the generator running sound will start immediately. Furthermore, remember, the activation sound is of the engine starting up, so we have a sound that plays straight away when we activate the switch, which is played by the switch script itself, but then after the activation delay is over, that sound will be over and the engine sound will be enabled. And we set the activation time so that the generator running sound overlaps slightly the engine activation sound so that we get a seamless engine start into an engine running. The other object we enable is called audio announcement. This is a game object that once again just has an audio source on it that plays that message of the public announcer saying that we are in lockdown. So to understand how this works a little better, so we can simulate what our script will do, I'm just going to activate play mode and I'm going to walk over to the generator so that we can hear what I'm doing, because the listener will be close to the sounds that I'm making. So let's go over to our generator, and then I'm going to sort of minimize the game window. I don't really care what's happening in the game window at the moment. Okay, so remember, our generic switch trigger activates the audio announcement game object when it's activated. So let me simulate now what our switch will do when it activates the audio announcement game object. There will be a short delay which is built into the audio file deliberately, and then we will hear the message start to play.
Attention all personnel.
At the same time, we will also activate the engine sound.
Emergency broadcast channel. Quarantine zone A7 has been breached. All affected personnel.
Okay, so we understand how powerful turning objects on and off are, but let's have a look at some of the other ones just so we're totally sure on this. So the next one I want to look at is a game object called dynamic lights. If we look at this in the scene hierarchy, we'll see it's a multi-object construct that actually contains 8 light sources. These light sources, and you can see all of their icons on the scene view, are simple point lights that have been placed in front of the light sources. They're going to be disabled by default, so let's turn them off at the moment to see what it will look like at level startup. So at the same time that we switch the materials of these lights so that their bulbs start to glow white, we also enable this dynamic lights object, which has several lights as children which all come on at the same time, bathing this whole area in the white light. And of course it looks like the light is coming from the physical light sources because of how we've positioned them. These are cheap lights, we don't have them casting shadows, at least I don't believe we do. No, they're all non-shadow casting lights. They're just to make a nice white effect so it looks like the lights are actually working. So we've now seen that our generator will also turn on all of those lights, so it's doing quite a lot. But by far the most interesting bit is the final object that is activated by our switch trigger, and that is the computer screen with power. So to understand that, let's go into the computer room and look at how our computer puzzle has been set up. So what I'm going to do is, in the scene hierarchy, you can see there are 2 game objects. There's one called computer screen no power and one called computer screen with power. Let me turn both of those off at the moment. Now, we've been in this level long enough now that you've no doubt seen this computer monitor before, and will know that we can't really change it or delete it from the scene that easily because it is baked into the background geometry. So what I do instead, because I want to get rid of this blue screen and just have it black, so I created a cube and put a black material on it, and I pushed it into the TV screen so that it covers up the blue screen. And this is the object that is on at application startup, right? So when we come in here, it looks like the computer is off. If we go back to our generic switch trigger again, you can see in the object deactivators that we enable this object, this black screen object, when we deactivate our switch, which means we also turn it off when we activate our switch. So if we were to activate our switch, this would happen, right? Which still doesn't look good, except for the fact that in the activation list, we turn on the object computer screen with power, which is this one here. The computer screen with power is a game object hierarchy in its own right. It contains a number of lights, it contains a trigger that detects when we're inside it pressing the E key, and it also contains its own lockdown trigger script for managing the deactivation of the lockdown procedure. Now, this puzzle here is a separate puzzle that we're going to look at after we've covered the generic switch script, but the whole point here is that by turning on that game object, we've turned on an entire sub-hierarchy of objects, which has added a whole new puzzle to the game. So let's just break it down very quickly. This object, first of all, has a cube on it, right? Which has a material on it, and the material is either of the computer lockdown screen or of the computer lockdown deactivated screen, which is the blue screen, which we saw when we played through it just now. It also has a number of lights in its hierarchy. Now, at the moment, both of them are active at the same time, but in reality, only one of them will be active, but this is controlled not by our generator switch, but is controlled by the lockdown trigger switch, which is on this very specialized game object. So you can see that when the scene starts off and the power generator is first turned on and lockdown is activated, we have this lockdown screen here, and we also have this red light on here. It's a spotlight, I believe, casting red onto this wall. But when we deactivate the lockdown, this texture on here will be changed to the blue texture, the red light will be turned off, and the blue light will be turned on. But once again, this isn't done by our generic trigger script. It is done by our lockdown trigger script, which is on this actual game object. So all our power generator switch is doing is just activating this sub hierarchy. And finally, you can see that the computer screen UI is a world space retained mode Unity UI. And the slider bar here, as you can see, is a standard UI element, which makes it very easy for us to just alter the value of that element and make that slider go along from 0 to 100%. And the same is true of that line of text where it says press use to turn off lockdown. We can change this to anything else we want simply by selecting the hint text UI element underneath the computer screen UI canvas game object, and we can change the text there. Okay, so let's put this back to its starting position with computer no power activated. So back in our unfinished version of the Creeper project, the first thing we have to do before we write any scripts is configure the scene and bring in all of the objects that we need in the scene so that they are ready to receive our scripts. That's going to involve placing the generator mesh into the scene and configuring its material. It's going to involve placing lots of white point lights over by the elevator shaft, and we're also going to need to generate an animation for the generator's button. So let's now go down in the scene view to the location in the level where we wish to place the generator, which is about here. Fortunately, the generator model is already imported into our project. We did it several lessons ago when we imported all of the other Creeper assets. So let's go and find it in the project view and drag an instance of it into our scene. So selecting the project tab, I'm going to drill down into the Dead Earth folder, into the models folder, and then into the scenery folder. And there you can see we have a model called generator. Let's drag it into the scene. As you can see, it's very small at its default scale. So let's adjust this via the model's import settings. The scale factor is currently 1. Let's set it to 2.5. Then click apply. That's the size we want our generator to be. Let's rotate that around a little bit, like so. You can see at the moment that the generator doesn't have its material on it. When we imported the model, we also imported a material called mGenerator. Just in case you didn't see what I did, this is in the materials folder in the same folder that the generator model is in. So let's drag and drop that onto our generator model. Nothing changed because when I select the material, you can see in the inspector, it's currently set up as just an ugly grey diffuse material. So let's assign it the maps now that it needs. So I'm going to lock the inspector of this material, step up into the scenery folder again, and then down into the textures folder. There you can see the diffuse and normal map that this material needs to use. So let's drag over the diffuse texture into the albedo slot and drag the normal map into the normal map slot. The normal map looks pretty tame, so let's ramp up its contribution to about 2.41. And I'm also going to slide up the metallic slider to about 0.6 and also slide up the smoothness a little bit. You can just see that looks a little bit better, looks a little bit more metallic now. Of course, these aren't proper metallic texture sets, so we can't treat them like PBR textures, but I think adding a bit of metal to it just makes it look a little less plasticky. Like I said, about 0.6. Finally, we will alter the albedo color and we'll set that up to white. Let's have a look what that looks like in the scene view with lighting. Yeah, that looks about right. Now at the moment, this generator looks like it's been assigned its materials properly, but we have a sub-object in the generator, which is this little light here. Selecting that little light, you can see it uses the same material by default as the rest of the generator, but we wish to assign this its own special material so that we can change the emissive color, as we saw a few moments ago. So what I'm going to do is step back up into the scenery/materials folder, and I'm going to create a new material. Now in the project I just showed you, I called this emissive green. Now that's a somewhat knobbish name that I gave the material because first of all, it doesn't even start off green, it starts off emissive red. I should probably call it something a little bit more descriptive, such as the generator light. So I'm going to call this generator light, and I'm also going to unlock the inspector so that I can see that material. As you can see at the moment, it's just a default material. Let's drag it onto our little light there. Not much to look at the moment, is it? Okay, let's set the albedo color down to black. Turn on emission and set its emissive color to red. Although this looks fine at the moment, experience tells me that when we add the bloom post-processing effect later on, it will help us to bloom this light if it is in the HDR color range. So I'm going to scale this maximum red color by a further 1.4. Doesn't need to be exact, 1.4-ish. Of course, this generator light material is one of the materials that our generic switch trigger script will alter when we activate the generator. What I'm going to do now is select the generator and move it into its final position. It's just roughly placed at the moment. So what I'm going to do is I'm going to copy and paste in the values I used in the original Creeper project, and then I will zoom in on the inspector so that you can make notes of the position, rotation and scale. So let me zoom in on the transform so that you can pause the video now and make notes of the new position and rotation that I've moved the object into. As you can see, I've just pushed it down this little passageway a little bit, so we have to travel into a dead end where we could get blocked off by a zombie coming in behind us. Let's now add some lights to this that will be used to create the red light and the green light that will illuminate the area based on what colour the material of our generator's power light is. So because I want to see how the light is going to affect the scene, I'm going to temporarily enable lighting in the scene view, like so. Hey look, you can see our emissive red power light now really glowing up. I'm now going to right click on the generator object and I'm going to choose to create a new light. I'm going to create a point light. And I'm going to set the colour to red and the range down a bit to, I don't know, about 2.8 maybe. Doesn't show up very well at the moment because we haven't really got it in the right position, have we? We want it to be sort of something like this. So what I'm going to do once again is I'm going to pause the video and I'm going to copy and paste the values in, and then I will zoom in on the transform so that you can make notes and copy those values into your own project. There's the final position. So once again, I'll zoom in on the transform, let you take note of the position vector that I've used for it. And I think what I'm also going to do is, this light isn't really affecting the scene at the moment, but I don't want it to have too large a range because a little power light wouldn't be illuminating walls and geometry way back here. So what I'll do is I'll turn up the intensity, okay, so that'll make it brighter without increasing its range. And I'll put the intensity up quite bright to say something like, I don't know, 4. Yeah, that looks good to me. And then what I'll do is I'll rename that game object in the scene hierarchy and I will call it light off. In other words, this is the light that should be activated when the generator is off. So now we need to create light on. Well, that's not too difficult. We'll just duplicate light off. We'll disable the original light off and we'll rename this object light on. And we'll change the color of the copy to a green, probably something, I don't know, like that. Now, of course, this game object should only be enabled when the power generator is on. So let's turn that off for now and re-enable light off, so we see what the generator looks like in its starting state. And next, I'm going to add 2 more child game objects that will be the audio sources that are going to be used for the running engine, and also that game object that we call timeline audio that our generic switch will use to play the engine startup and the engine power down sounds. So with our generator game object selected again, let's select audio and choose audio source, and I'm going to rename this timeline. And I'm going to leave the position where it is at 000 offset from the generator. And of course, our script is going to be responsible for setting the audio clip of this based on whether we're powering up and powering down. However, what we do wish to do is set the output audio mixer group, and I'm going to choose to assign that to the scene audio mixer group. Makes sense, as the power generator is an item in our scene. It's one of the scene sounds. However, we wish to untick play on awake. It will be our generic trigger switch which will be responsible for telling this audio source when to play the engine startup and power down sounds. Let's now duplicate our timeline game object and rename the duplicate engine sound. This audio source once again needs to be assigned to the scene audio mixer group, but it does need to be configured to play on awake. This is the game object that will start off disabled and will be activated when the power generator is switched on. When this object is enabled by our generic switch trigger, it should start playing the sound of the engine of the generator ticking over. So let's go and find that sound now. I'm going to drill down into my sounds folder, into my scene sounds folder, and there should be something in here, there you go, called generator running. Let's listen to it. Okay, looks good, but let's force it to mono, and let's set it to PCM uncompressed, and click apply. Then we can select our engine sound game object in the scene, and we can assign that generator running audio clip to the audio clip field of the audio source. In my original version of the Creeper game, I found that the volume of this engine sound should be around about 0.3. So let's set the volume property of the engine sound audio source to about 0. I think it was 36. while we're here in the Scene Sounds folder, let's take a look and configure our generator running and generator stopping sounds, which will eventually be added to an audio collection that our generic switch trigger will play. So here is the generator starting sound. So let's force that to mono as well. We don't want compression, so set it to PCM and press apply. And here's the generator stopping sound. Okay, so once again, let's force that to mono and set the compression format to PCM and click apply. And in fact, while we're here, let's also look at the generator button sound. That's the sound that our animator is going to play when the button is pressed in, or when it's pulled out. So once again, let's force that to mono while we're here, set the compression format to PCM and click apply. Okay, so there's only one other game object that we need to add to our generator construct, and that is once again another game object with an audio source that is going to play that announcement over the public address system when the generator is activated. Now, if you look at the geometry for this scene, you'll see that there are several speakers placed throughout it. We have it here, we have some here, we have some here, and we have one here. So the correct way to do this really would be to create several audio sources all playing that announcement, so that as we walk around the level and we get closer to these speaker systems, we really hear the sound change as it should. However, I didn't do that. I just decided to place one audio source in the center of the scene for this, but it would be quite easy to do. All you would have to do is, instead of creating one audio source, create 4 audio sources, parent them to a container game object, and the parent object would be the object that your trigger switch activates and deactivates when the generator powers up. But like I said, I'm not going to do that. I'm just going to create one audio source. In reality, what I found was that because the generator is next to this speaker system, it was actually too loud here, and then when you went in the middle, it got quite quiet because you weren't near any of the speakers. So I found that it was just a little more manageable putting the audio source in the middle. So let's create a new game object of type audio, and this will be an audio source. This once again needs to be assigned to the scene audio mixer group, and it needs to be assigned that announcement. So where was that? Let's go into our Scene Sounds folder again. There it is. It's called Message EQ'd. You'll notice there is deliberately a delay at the front of this audio clip, because our generator's switch will activate this sound immediately at the same time that it activates the animation of the button being pushed in. And I didn't want both of those sounds to start at the same time. So I've left a little gap here so we get to hear the button being pushed in, then a little bit of the engine starting up, and then we start to hear the announcement. And of course, here is the announcement.
Attention all personnel. This is an automated message being broadcast on the Simtech Emergency Broadcast Channel. Quarantine Zone A7 has been breached. All affected personnel should implement emergency shutdown protocols before proceeding in an orderly manner to a designated safe zone. Finally, do not panic and stay calm. We have the situation fully contained.
Okay, so we need to set that to mono as well. And how long is that message? It's quite long, so I think we will actually leave this with Vorbis compression and just do decompress on load so it doesn't take up too much memory on disk, and then we'll click apply. And then we'll select that new game object that we just added. Where did I add it? Oh, there it is, audio source. And we'll rename that public announcement. And we'll assign to the audio clip property of that audio source the Message EQ'd audio clip. Once again, this needs to be configured to be played on awake, because this game object is also going to be turned on by our generic trigger switch on the generator. And I set the volume of this to about 0.34, I believe, in the original project. And what I did to make it more controllable so it doesn't fall off completely at the outer extremes of the level is I moved the spatial blend to about 0.7, okay, so that you can always hear it a little bit wherever you go in the level, right, because it's kind of 30% two-dimensional. Just move that up a little bit to about 5.4 on the Y, I think is where it was. Yeah, about there. And then what we'll do is we'll take that public announcement game object and we'll make it a child of our generator also, and we'll disable it by default along with the engine sound. Oh, by the way, I forgot to set the spatial blend of the engine sound to fully 3D and also of the timeline audio to fully 3D as well. Very important. Oh, and something else I need to remember to do is the engine sound needs to be set to loop because it's a looping sound, and we'll also turn that off by default as well. Okay, so our generator construct is pretty much set up so that it's ready to receive its script. So we'll leave that for now. And the next thing we'll do is we'll go over to the other side of the level and we will start placing the light sources in front of all of these light meshes. So let's start by creating a point light. So I'm going to go to the game object menu, to the light submenu, and choose to create a new point light. By default, it's set to white, but I'm going to set the range to about 3.6. And I'm going to set the intensity to 3.5. And then what I need to do is position this light so it's right in front of the actual light mesh. So I think probably the best way to do this is to go to ISO mode. It needs to be centered right in the middle of that pole, doesn't it? Yep, looks good to me. Let's go back into perspective mode again. Okay, so what we'll do now is we will rename that and call it dynamic light. And then we'll duplicate it. And we'll slide it over there. And then we'll duplicate it again. And we'll slide it up there. We'll go in ISO mode in a minute and just check that all of these things are placed exactly where we want them. We'll duplicate that again. And we'll slide it over there. Any more? No, that's the 4 on the elevator shaft. So let's now go back into isometric mode and check that they are all lined up where we want them. I think it's just really from the front view they're not lined up, isn't it? So we want that to be sort of there, like so. This one's not lined up either, is it? Oh, there's some more lights around the back. I didn't see those. Okay, so let's go back to perspective mode again. Let's duplicate that light again. Let's now move it over to these on the back here. Once again, we'll go into ISO mode, move it down in front of that light source, and then we will go around and make sure it's lined up in front of it as well. And then we'll duplicate that one and we'll flip it to the other side, which more or less looks lined up. Okay, so we've got a few more lights to place. We've got one here and one here. I think that's the only other two, isn't it? Okay, so once again, let's select one of our lights. Let's duplicate it. Let's bring it over here. And then let's go into isometric mode again and go to one of the extreme views so we can see what's going on. Yep, that one looks good. Where was the other one? It was around here, wasn't it? So duplicate again. That looked lined up to me. Probably needs to go up a tiny little bit like so. Okay, so the only thing we need to do now is we need to add lights here that's going to light up these big floodlights. And I did this in the original Creeper by using just one spotlight, so it wasn't too expensive, okay? So what we'll do now is we will create a new light that is a spotlight. Oops, I added a point light by mistake. So let me rename this object spotlight to begin with. I'll call it big floodlight, like so. And then I will change the light type to a spotlight via the lights inspector. Okay, let's move this thing into position now. Let's give it a really high intensity at the moment so we can see exactly where it's facing. We'll move it out. God, it's a pain in it, this. Let's now rotate it down. And what we probably want to do is give it a really, really big angle. Let me go into isometric mode a minute and just see if this is roughly where I think it is. It probably needs to be in the middle of those lights. It needs to be rotated around a little bit more so it's coming out evenly. We'll move it back even a bit more again. And we'll give it a really wide spot angle of like 166. Now clearly that looks a bit whited out, doesn't it? Okay, so we'll set the intensity to something like 0.9. And we'll set the range to about, I don't know, about 115. Well, we'll go with that for now. So that's all of our lights now set up in place. So what we want to do, I just noticed I called all of those lights dynamic lights instead of dynamic lights, but I can't bother to select each one and correct the spelling by putting the C on the end. So what we'll do now is we'll create another empty game object and we'll call this dynamic lights. And this will be the container under which all of those lights will be stored. and I'll just reset the transform to 000, select all those lights, including the big floodlight, and make them children. And the great thing about this now is in our generic trigger script, in the activated objects list, we can just add a reference to this one parent object, because we know that when that one object is turned on, all of the child lights turn on as well. And we'll turn it off by default so that the lights are off at scene startup. Okay, so let's press play now and just make sure that everything we've done looks and sounds correct so far. I mean, nothing's going to look too great at the moment because we haven't got any screen effects on like bloom and tone mapping and stuff, but we'll get an idea. So let's turn on the dynamic lights first of all, see what that looks like. Yeah, I mean, it looks weird at the moment because the actual materials of the light bulbs haven't swapped over to show themselves glowing white, but I think that'll be okay. When we've got bloom on, that'll be whited out a bit more, so it will look quite bright. And let's now go over to the generator, and while we're over by the generator, turn on some of those play on awake sound sources that we configured and see if they sound about right. Here we are over by our generator switch. Let's first of all try the engine sound by turning that on. Sounds about right, and then turn on the public announcement. Remember, there's a delay at the beginning of that WAV file.
Attention all personnel. This is an automated message being broadcast on the Simtech Emergency Broadcast Channel.
Okay, I would say that needs to be louder.
Has been breached. All affected personnel should implement emergency shutdown protocols before proceeding in an orderly manner to a designated safe zone. Finally, do not panic and stay calm. We have the situation fully contained.
Okay, so far so good. The sounds all sound a bit dry at the moment. What we're going to do eventually is add some audio effects to our mixers so that those sounds are all reverberated and they sound echoey, as they would do in real life in this sort of environment. So the next thing we need to do is we need to create the animation for our little generator button being pushed in and out. So let's do that next. Okay then, so after the last lesson where we learned how to animate the elevator, we are now veterans at creating animations in Unity. And it really is delightfully easy to create an animation for any object in Unity using Unity's animation window. We need to create an animation for the button object, which if you look in the hierarchy is the first child of our generator. I'm going to turn lighting off in the scene view so we can see this object a little more clearly. So as you can see, the button object is a separate sub-object that we can move around and animate. So what we want to do is create one animation that is going to animate this button along its local z-axis, and then another one that's going to animate it back out again to its original position. So let's make sure before we do anything that we go up, and if you've got the tool handles mode in global, put it back into local so that we get the local axes back. Okay, and what we want to do is, if I zoom right in on this thing, is we want to move it into about there. So look at the z-axis, 0.47. That is the final keyframe that we wish to stamp into the timeline on our power on animation. And of course, our power off animation is going to have the button start at z equals 0.047, and then its last keyframe will be at 0 again. Okay then, so with the button selected, let's go to the window menu. And let's call up the animation window, and let's choose to create a new animation for the button object. It's asking me where I wish to store this animation, and by default it opened up in the interactive folder. But if it didn't on your computer, then once again just browse through the project folders, and in the animations folder you will see the interactive folder, and you'll see that our elevator animation that we created in the last lesson is in there, and we will call this power on, and we'll click save. Then, making sure we have the button game object selected, we'll press record mode, and I don't know why, but there's a button here that says add keyframe, and I'm supposed to be able to just click that and that will add a keyframe into the timeline. But as I can't do that, I'm going to have to do it that silly way by putting some temporary value into the Z component and then setting it back to 0 again, like so. And now I have the first keyframe of my animation. Okay, now I'm going to drag the timeline along. Let's put it about 0.15 seconds there. And it's here that we will move our button object to 0.47, we said, didn't we? So I'll type that in manually so I can get an accurate Z component for that keyframe. And let's see what that looks like. It's probably a bit fast. It should be probably half that speed. Yeah, I reckon that's about the right speed. Actually, what we could do, we don't really need 60 frames per second for this animation, so let's put it back to 0.15 and let's set the number of samples from 60 frames per second down to 30 frames per second. That should now give us the same speed because we are executing the frames at half the speed. Let's have a look at that. Yeah, perfect. Okay, so let's now create a second animation for this button that does the reverse. Now we don't have to close down the animation window and open it up again because there's this little drop down here that will show you all of the animations that are available for the object that you have selected. Now we obviously only have one called power on, but when you open up that drop down you get to create a new clip right there. So let's create another clip and call this power off. Once again, I'm saving this in the interactive animations folder. Like so. And we'll set this down to 30 samples per second and we'll press record, and this time we know that the first keyframe needs to be at 0.047 on the z-axis, and then we'll scroll along to 0.15 and we will then reset the z position component to 0, which is its original value. Okay, so once again, if we want to see what this looks like, that's it sliding back out again. Okay, so let's now just turn off record mode, and look, if you drop down that little drop down now, you can see that there are two animations listed and we can select both of them for previewing. So that's the one where it pushes in and this is the one where it pushes out. So let's close down the animation window and drill down into our interactive folder, and let's select the power off animation and let's untick loop time. This doesn't need to be a looping animation, and we'll do the same for the power on animation as well. Also notice if I select the button game object that just as it did with our elevator, Unity has added an animator component to it, and it's also created an animator controller called button, which at the moment it is put in our interactive folder, but we like all of our controllers to be in our animator controllers folder, so that's where I will drop it. Okay, so let's now open up the animator controller by selecting the animator controller of our button and opening up the animator window and seeing what we have here. So press the parameters tab and let's add a new parameter to this animator of type bool and call it activate. Like so. Then we're going to create a new empty state. Let me rename that and call it empty. And we will make this the default state for the layer so that when the game starts, our button isn't animating in any way. So let's make a transition from this state into the power on state. And of course the condition for this should simply be that activate equals true. Then we're going to transition from the power on to the power off animation when activate is false. Now remember, once we transition into this state, the last frame of this state, because it's not a looping animation, will be the final position that the button needs to be in to be on. So we will remain in this state with the button just stuck at its last keyframe, which is exactly what we want. The next time we activate the button, we need to transition back from the power off position into the power on position. And this of course will simply be when activate equals true, just like the initial transition from the empty state does. We'll turn off has exit time. We don't need any of those has exit times set on any of these transitions. And we should be able to press play now, and in the scene view, what I'll need to do is I'll move the animator over here like we did when we were testing our elevator platform last lesson. And I'll press play and I'll zoom in on the scene view so we can really see the button up close. And let's set the activate boolean in the button's animator to true. And there you go, it goes in, and just so you can see how this works, you can see now in the animator, let me select the button so I get a live link to the animator, we are in the power on state, but it's stuck at the end of the power on state in its last keyframe, which is exactly what we want. But then if we untick the boolean, we're going to transition into the power off state, and the button will then remain in that state in the position described by the last keyframe of the power off state until we activate it again. And as you can see, this works perfectly. So I think the final thing we're going to do in this lesson is create a state machine behavior that we can add to the power on and power off states that is going to play the metal screeching sound when we activate this button. And then our scene is fully prepped, ready for us to come back in the next lesson and write our material controller class and our generic switch trigger class. So that'll be a pure coding lesson for the most part. Okay, so let's drill down into our scripts folder and go into our interactive items folder. Actually, I'm not going to put this in the interactive items folder. I think I'm going to put this in the audio folder, and I'm going to create a new folder in there called state machine behaviors. And then I'm going to drill down into that, and I'm going to create a new C# script. and I'm going to call this audio on enter. This is going to be the script that will be assigned an audio collection. When we enter that state, it will automatically, in its on state enter function, select a clip from the collection and play it. So let's now open up our audio on enter script in MonoDevelop. We'll put the curly brace on the second line because we're not animals. We will delete the start and update functions because this isn't even a mono behavior. This is going to be derived from state machine behavior. So let's delete mono behavior as the base class, and let's change the base class to state machine behavior instead. So this script is going to need only two serialized variables so that we can assign it an audio collection and the bank that we wish to use in that audio collection via the inspector. So I'll create a serialized field of type audio collection called audio collection with an underscore, which I set to null, and I will also add a serialized integer called bank that is set to 0 by default. Now the only function we're interested in overriding in this particular state machine behavior class is the on state enter function. If this script is on an animation state, then Unity will call this function on the first frame that the animation state has been transitioned into. So that's exactly where we wish to trigger the sound. So we'll first check that we have a valid reference to the audio manager singleton in the scene, and we'll also check that we've been given a valid reference to an audio collection. If either of these conditions are not met, we will simply return without doing anything. Otherwise, we will just do what we have done dozens of times before. We will call the audio manager's play one-shot sound function. So I will say audio manager.instance.play one-shot sound. For the first parameter, we will pass in the audio group that is specified in the audio collection. For the second parameter, we will use the audio collection property of our audio collection, passing in the bank number so that we get back a random clip from that bank. And for the third parameter, we will get the animator that Unity has passed us. Remember, that's the animator component that is on our button game object. And then we will get its transform and the position from that transform. So we're basically saying we want the sound to happen at the position of our button. We will also fetch the volume from the audio collection, the spatial blend from the audio collection, and the priority from the audio collection. And that is our audio on enter script done. And in fact, this generic script can be used all over the place. We'll probably be using this quite a bit in our FPS ARM system when we develop that later on. So let's save that script off, go back to the editor and check we haven't got any errors. And then let's add an instance of that script to our power on state, and also an instance to our power off state. So in order to test this, we need to create an audio collection with the button screeching sound in it. It's only going to be one sound in this collection because we only have one button screeching sound. So I'm going to select the audio collections folder, which is within my sounds folder. There it is. And with the audio collections folder selected, I'm going to go to the assets menu and choose to create a new audio collection. And I'm going to call this generator power, like so. Then I'm going to type in scene as the audio group with a capital S. I'll set the volume down to about, something like 0.3. We'll leave the spatial blend at 1, fully 3D. We only want one clip bank, so I will reserve room for one clip bank there. And we only want one clip in that clip bank. And that is going to be our button screeching sound. So I'm going to lock the inspector, drill down into my sounds folder, into my scene sounds folder, and I'm going to drag the generator button sound from the project view and drop it in its respective slot in the inspector. Then I'm going to unlock the inspector and I'm going to select the power on state in our buttons animator, and then I'm going to choose the audio collection. So I'm going to open up the audio collection picker and choose generator power, and I'm going to do the same in the power off state as well, assigning it the generator power audio collection, as we don't have separate sounds for power on and power off. Okay, so let me make sure I untick the activate boolean. Let's press play, and I'm going to walk the camera over to the generator. Otherwise the audio listener, which is on the FPS rig, may be too far away from the button sound and we might not hear the sound clearly. Okay, so here we are. Now let me go into the scene view and zoom in on there. Let's now set the activate boolean to true. How perfect is that? Cool stuff, huh? Okay, so I'm going to leave it there for this lesson. When we come back in the next lesson, we'll first start by writing our material controller script. That's important because we can't write our generic switch trigger without it. And then we will write the generic switch trigger itself, which will put all of this stuff into motion. Okay, guys, thanks for listening. I will see you next time. Bye-bye now.